Alright, grade 11 exponents. I have a few questions that I want us to look at. The very first one, show that a 5 times 2 raised to x minus 2x plus 2 is equal to 2 raised to x. Show that the left hand side is equal to the right hand side there. My left hand side here is 5 by 2 raised to x minus 2x 2 raised to x plus 2, and this will give me I need to separate here 5 2x minus 2x by 2 to the power of 2. Remember the first law of exponent, when we have 2 raised to x times 2 raised to 2, we just add the powers because the bases are the same. Now we have common factors here, so this is going to be equal to raised to x in bracket. If you get rid of this here, if we factor out this, we are left with a 5. If we factor out this, we are left with 2 squared, which is equal to 4. So this is equal to 2 raised to x multiplied by 1, which is equal to 2 raised to x, and that is equal to our right hand side. We have shown what we were required to show here. And the second one, show that 9 raised to x plus 3 2x plus 1 is equal to 4 multiplied by 3 raised to 2x. Alright, we have a base 3, we have a base 3 there. There is a 9 which we can write as an exponent with base 3, so that will be 3 raised to 2 with an x there, right? And it will be 3 raised to 2x by multiplying this 2 by the x plus alright, I'm supposed to say the left hand side there. My left hand side is equal to that, and this is 3 2x plus 1, and this 3 2x plus 3 2x, I'm separating this one by 3 raised to 1, and then we have common factors between these two terms. Factor out 3 raised to 2x. Inside, this is multiplied by a 1 here, like a coefficient, so we're left with that 1 plus, when we factor out this, we are left with 3, and this is equal to 3 raised to 2x. This gives us 4, which we can write as 4 3 raised to 2x, which is equal to our right hand side. That's what we were required to show there. Alright, this was the first question, and then let me say number 2 here. I have 8 raised to n multiplied by 6 raised to n minus 3 multiplied by 9 raised to 1 minus n. All this is being divided by 16 raised to n minus 1 multiplied by 3 raised to a negative n. Simplify. Now for us to simplify, we should be able to notice that we have a base 3 here, and then 9 can be written as an exponent with 9 can be written as an exponent with base 3, and then 8 can be written as an exponent with base 2, 16 can be written as an exponent with base 2, and then 6 is a product of two bases. 6 is a product of two bases, that is 2 and 3. Let's do that. 8 is 2 raised to 3, and there is an n outside, and then 6 is 2 multiplied by 3 with an n minus 3 there, and then this is 3 raised to 2 with 1 minus n all over. This is 2 raised to 4 with an n minus 1 there, and this is 3 negative n, and then this is going to be equal to 2 3n multiplied by, separate here, is 2 n minus 3, and then 3 n minus 3. Remember that law which says a b raised to m is equal to a m b m. Remember this law, that's the one I'm using here. And then the third one there, multiply 2 by this one, that's 3 raised to 2 minus 2n. 2 multiply this, and then 4 multiplied by this one also, so is 2 raised to 4n minus 4. This is multiplied by 3 negative n. Now we have simplified the bases. The only basis that we have now is 2 and 3, so we can put everything together. 2, there is a 3n there. Using the first law, these are multiplying, so we add the power, so this is plus n minus 3. Do we have another 2 here? No, but we have a 2 down there. It's down here, so using the second law, we subtract. Please remember to put brackets there. 4n minus 4. So we have this from the first term, this from this term, minus this from here, and this is multiplied by 3. We have n minus 3 minus 3, and then they're multiplying, add the power, so plus 2 minus 2n, and then this is being divided, so it's minus, it's a negative there, negative n, and this should be equal to 2 raised to 3n to make it 4n minus 4n, that's a 0, and then negative 3 minus a negative 4, that gives us a 1 there, and then 3n minus 2n is negative n minus n. The n becomes 0, and then we have negative 3 plus 2 is negative 1. So here it gives us negative 1. It is having a negative, so we bring it down. So we have 2 raised to 1 over 3 raised to 1. That is equal to 2 over 3. And then I have another one. We have another one, that is number 3. 4 raised to x plus 2 raised to 2x minus 1 all over 2x minus 1. Simplify. Alright, I have a base 2, I have a base 2. This 4 also has to be written as an exponent with base 2, that is 2 squared raised to the x there plus 2 raised to 2x. There is minus 1 here, let's separate, so it's 2 negative 1 there. This is over 2, there is a 2x, and then separate, we have a 2, there is a negative 1 there. So 2 raised to 2x minus 1, I've written it as 2 raised to 2x times 2 raised to a negative 1. And then this is 2 multiply there, 2 and 2x plus 2 raised to 2x to negative 1 over 2 2x to negative 1. And then on the numerator we can factor out 2 raised to 2x there. So it's 2 raised to 2x bracket, here we are left with a 1, here we are left with plus 2 raised to negative 1 over 2 raised to 2x multiplied by 2 negative 1. Then we can cancel these, they are the same, so we are left with 1 plus 2 raised to negative 1 becomes 1 over 2 there, and then over 1 over 2 also, 2 raised to the power of negative 1. This is equal to, this is 2 over 2 plus 1 over 2, that's 3 over 2 divided by 1 over 2 is the same as multiplying by 2 over 1, and this is equal to 3. This is number 3, and then number 4. Number 4, we have 2 raised to 2x there minus 2 raised to x. This is all over 2x, and then minus 1. How do I do this? Let me rewrite this one to be 2 raised to x is all raised to 2 minus 2 raised to x over your 2 minus 1 there, and then from there we can factor out 2 raised to x there. Here is two of them, so we're left with 2. Sorry, we're left with 2 raised to x, the 2 raised to x there, minus 1. So if we factor out this, we are left with a 1 here over 2 raised to x minus 1. Now we have 2 raised to x minus 1, 2 raised to x minus 1. So these can be cancelled. We are left with 2 raised to x. And then the last one, it's 2 with a 2x there minus 1 over 2 with an x plus 1. Alright, how do we do that? Here we have 2 raised to 2x minus 1. This is 2 raised to x plus 1. We can rewrite this to be 2 raised to x, just like here, but this one is raised to 2. And then this is minus 1 over 2 raised to x plus 1. Okay, this also can be raised to 2. Do you notice that we have a difference of 2 squares? The difference of 2 squares will give us an addition there. So this raised to that plus 1 and then minus 1. This is the expansion of the difference of 2x there. Not expansion, but factorization of the difference of 2x, and this is 2x plus 1. There we are, 2x plus 1, 2x plus 1. So these ones can be cancelled. We are left with this one, 2 raised to x minus 1. That's all I have for now. Just remember, practice makes perfect. So practice as many questions as you can.